The flame ionization detector, also known as FID, is an important detector used for gas chromatography. The FID consists of a flame, a current circuit, an electrometer, and an exit for the carrier gas. Let's understand two important concepts before we understand how the FID actually works. Firstly, the formation of a flame is as a result of the introduction of hydrogen and oxygen gases from the inlets located at the bottom of the detector. As long as these gases are being introduced, the flame can be maintained. One end of this flame acts as a cathode and the other end acts as an anode. The second concept that we need to understand is that the external circuit here has a battery attached to it. There is a constant flow of current from the negative terminal of this battery. However, this current does not complete the circuit because of two reasons. A, the flame has extremely high resistance, and B, the flame contains a negligible number of ions or charges within it because there are no ionizable compounds in the flame right now. Now let's understand how FID detects and quantifies our analyte. There is an inlet at the bottom here, which introduces the contents of the column into the detector. Let's say we have a carrier gas coming in from the column and entering the detector. This carrier gas is an inert gas, which is why when it enters the flame, it does not get ionized. It heats up and exits the detector from up top. Eventually, an analyte enters alongside the carrier gas. Once this analyte reaches the flame, it combusts and splits into two parts, an anion, which is a negatively charged ion, and a cation, the positively charged ion. The anion is attracted to the anode and stays on one end of the flame. The cation similarly reaches the opposite end of the flame. Let's have a look at it with a zoom. The analyte and carrier gas enter, carrier gas leaves, analyte gets combusted, it splits into two ions, and these ions arrange themselves as per the charge they possess. This basically forms a bridge for completion of the circuit. Now, the current that is pushed out from the negative battery terminal follows the same path, reaches the flame, but instead of the current flow getting terminated abruptly, the current uses the ion bridge formed due to analyte combustion. This helps the current pass through the flame, emerge from the other side of the flame, and enter the electrometer where it can be measured. And the reading on this electrometer is reflected on the chromatogram, which is how we know we have an analyte that is entering the detector. If we have a higher concentration of analyte molecules coming in, more of them will be ionized, more ions will help form a stronger bridge, and as a result, more current will be able to pass through the flame, and more current will be detected in the electrometer. This is how we detect and quantify the analyte using a flame ionization detector.